Hello there, and welcome to the B1 core practical for Osmosis. Today we're looking at how water molecules move through a partially permeable membrane using a potato and different concentrations of solutions. So, with all practicals, although this isn't particularly dangerous, we are going to wear eye protection, as we do in most core practicals we do in science. Now, the method for today's practical is going to require several different pieces of apparatus. First of all, you are going to need a potato. You're also going to need a ceramic tile, a scalpel, forceps, borer. You've got 4 different concentrations of sucrose solution, 4 different boiling tubes, and also the balances as well. We're going to need these to weigh the pieces of potato. So first of all, we need to bore the potato. So we'll teach it physics. No, what we really need to do is use a borer to create 2 centimetre cylinders using potato from the inside. We don't want the skin in this. So we're then going to push it out. So we've got this cylinder. We are going to do this 4 times for the 4 different solutions. To make it a fair test, we need to use the same potato to create all 4 pieces from this one. Because we don't want the skin on the potato, we're going to use the scalpel very carefully, and we're just going to chop the ends off. Because if we leave the skin on, it may not allow for the water molecules to move about as freely. So, to ensure that we control the variables of the size of the potato, we need to use a ruler to cut down and make it 2 centimetres long. So at the moment, our one is 2.5 centimetres, so we're just going to cut only a small amount, remove that from the scalpel, and now we've got our piece of potato that we're going to use in this study. The next part, using a paper towel, we're just going to dab off the excess water to ensure that when we weigh the mass of this potato, we're not picking up any more water than we have to. Once you've dried the potato of excess water, you're going to place it onto the balance and make a note of the mass on the front. So for us, it's 1.41 grams. So now we've got our mass of our potato, we're going to pour 0% sucrose solution. So this one is pure water. There is no sucrose in this one at all. I'm going to pour this into our first boiling tube. Using the forceps, we don't want to add anything to the mass once we've already placed it onto the balance. We're going to drop it into this 0% sucrose solution. I'll now measure and we'll do the 80% so we can look at the results at the end of the video. I've already placed the potato in the 20% and 40% solution. We're now going to measure the mass, the starting mass of the potato going to be used in the 80% solution. We'll allow this to settle, make sure it's the correct mass. So it starts off at 1.04 grams. We're now going to place that into the 80% solution. We're going to leave these for a period of time now to allow for the water to move between the boiling tube and the potato. Welcome back. So we're now going to look at our potato that we've left. We've left it for half an hour. You can leave it for as long as you want, but it has to be left for at least 15 minutes during this practical. So we'll start off by getting the 0% solution, the potato that was in there. We'll get that out first. We're going to need paper towel and also a beaker for the waste product. So we'll pour out first the 0% solution. And using our forceps, we'll take out the potato. We're going to dab this dry, same as we did when we looked at the starting mass. And that's to get rid of any excess water or 0% sucrose solution before we measure the mass again. I'm going to zero our balance. and we can see that it's increased in size and it's gone to 1.94 grams. Okay, so we make note of that as our finishing mass, and then we can move on and look at the 80% sucrose solution after this. So, same process again, we need our waste beaker, and this time we're going to empty the 80% sucrose solution, and we're going to take out the piece of potato there. And as we can see, it's already looking much smaller. We're going to dab it dry. And this time it has decreased, it's down at 0.55 grams. Okay, so we'll make a note of that as well, and then we can go on to our calculation at the end of this video. So as you can see, even visually we can see the difference in size. So this is the one that was in the 80% sucrose solution, and this is one in the 0%. And you can see that not only have they got wider, the length has also changed, because in this case the water molecules have left the potato, and in this case the water molecules have entered the potato. Now, with regards to the other two, the 20% and 40% sucrose solution, in the actual core practical, you'll make sure you have to measure these as well. As we're just doing a demonstration, in this case, we're going to focus on the 0% and the 80%. So now we have our final measurements, we can use these in a calculation to show the differences in the mass change between the 0% and the 80% solution. Now to do this, we have to use something called percentage change in mass. We can't just use change in mass because the starting masses of potatoes, as we measured earlier, are different. So to do this, we have to use this equation. So it will be final mass, take away initial mass, divided by initial mass, then times that by 100. So for the first calculation, it will be 1.94, which was the final mass in the potato in the 0% sucrose solution, take away 1.41, which was the starting mass, divided by 1.41, which is the starting mass, and then times that by 100. So that will give us 37.6%. For the 80% sucrose solution, it will be 0.55, take away 1.05, divided by 1.05, times by 100. And that will give us 47.6%. But in this case, it will be minus 47.6% to show that the mass has been lost in this potato, because the water molecules have left this potato, and in the 0% sucrose solution, they have entered the potato. So to explain why the mass in the potatoes changes, we're now going to look at a diagram to help us explain how osmosis works. Now on this side here, we're in a low solute concentration solution, so there's 0 solute in our 0% solution. That means there is lots more free water molecules to move around on this left-hand side. The dotted line in the centre, that represents our partially permeable membrane. In our case for the potato, it is the outside, the cell membrane of the potato, and that allows water molecules to move between it. So on the far side of this diagram, we can see there's a high concentration solute solution. Now because of this, the sucrose in there, the water molecules will stick to that sucrose because it's trying to dissolve it. So on the high concentration solute side, that means there are less freely movable water molecules, and in osmosis, water molecules will always move from an area where there is a large amount of freely movable water molecules to an area where there is a small amount of freely movable water molecules through a partially permeable membrane. So the reason we only speak about water molecules in osmosis is because the gaps in the partially permeable membrane are too small to allow anything else through. So the sucrose molecules are too large to move through. So if I make myself smaller, I can now fit through. So if we now link this to our practical and we look at the 0% solution, the side closest to me represents the conditions in the boiling tube in the 0% solution, and the side furthest away from me represents the conditions inside the cells of the potato. If we're thinking about the 80% solution, all we need to do is flip this diagram around. The side closest to me would then be the conditions inside the boiling tube in the 80% solution, and on the other side, the far side, that would be the conditions inside the potato cells.